In this one, we're going to talk about how to do a great conclusion for a binomial hypothesis test. So we've got a question, let's give it a read. So it says the chance of winning a prize out of a packet of crisps, a game, is 25%. Alex opens 20 packets of crisps and finds 10 prizes. So what are we thinking here? Well, 10 out of 20, this is hopefully making you think that maybe it's a bit more likely than it says. Investigate whether there is evidence at the 5% significant threshold, 5%, that the actual probability of winning a prize is greater. Okay, so our hypotheses, so the H0, H1, so when you do binomial, they're always going to be about the probability. Okay, the first one is going to be a 0. So it's going to be probability is equal to, and this is 0.25. So this is the default position, what we expect to believe, you know, what's kind of generally accepted, something like that. The other one is also always going to be about P for binomial. There's a couple of choices. So this is one of the choices, or this, but that's it. So we've got to read it. It says, investigate whether it's greater. And this kind of makes sense because this person, Alex, feels like he's won a lot. He's won half of that sample. So it feels like the probability is more. So when we do a hypothesis test, this is kind of what we're investigating. So this one here, if the result that we get is pretty normal, so we're going to test and we're going to see what sort of 10 or more out of 20 looks like. And if this is pretty normal, if this is sort of, you know, commonplace, something like that, you know, we'll just end up believing this one here, okay? For us to accept this other idea, okay, that the probability is actually greater, we've got to see something. We've got to have the data tell us that what's happened is special, it's significant. So let's take a look. Now, this is what the situation actually looks like. So 0, this is winning 0 prizes, and it goes all the way off to 20. But it's stopped because what happens is, well, if the probability is a quarter, yeah, like a quarter of 20 is 5, okay? So do you see that's the tallest bar? It doesn't mean that 5 is, you know, more likely than everything else and so on. It just means it's the single thing that's the most likely to happen. And can you see there, if this model is correct, about 0.2 of the time you'll get 5 out of 20. That's what that's saying. But that's not really what we want for a hypothesis test. What we've got to do is we've got to look at the value, and we've got to look at 10 or more extreme. You never test just the value on its own. You always test the value of or more extreme. So in other words, we're going to look at the thing happening 10 or more times, and we're going to see, you know, what's the probability attached to that. Okay, so what we're effectively doing is we're taking this part here of the diagram and we're saying, you know, how much of the time does that happen? Because if it happens a lot of the time, it means that what we just saw is not very special. It's pretty normal. Like, let me give you an example. If we said 6 or more, can you see there, you know, 0.15, 0.10, blah, blah, blah. Everything in this red box might make up something like, let's say, 30% in total. So if we see that happen, it's really not that special. It doesn't cause us to change our belief at all. We're only going to change our belief if this area, and for this question, it's 10 or more, if this is really special, more special than just happening 5% of the time by chance. So if we find this probability, and I'll talk to you how to find it in a second, what you'll find is 10 or more only happens this much of the time. This is like 1.4% of the time. So what happened here is actually quite special. Okay, so we would say, well, our null hypothesis is we believe what we are told. And if we get a special result, We believe that it's more than 0.25, and this is a special result, okay? So the probability of x being greater than or equal, it's always got to be 10 or more extreme, is 0.01386. And because this is sort of more special than happening just 5% of the time by chance, what we're going to do is we're going to reject what we have been told. We're going to reject H0 and we are going to accept H1. Always refer to H0 in your conclusion. So reject H0 and we're going to accept H1. This is not enough so far. We must put it into context. So we are going to accept H1 that the probability of a prize, and you really must be this specific, the probability of a prize in a packet. 1 year I marked you had to use really these exact words. The probability of a prize in a packet is more than 0.25. And there you go. That's what we kind of need to do to get a top answer. We need our hypotheses, we need to back it up with statements, and hopefully it's making a bit more sense now why we're saying what we're saying, because it's so special. We're rejecting what we've been told, and we've found evidence, if you like. Yeah, we've found evidence that actually it's different, that it is more. Okay, just very quickly, finding this out on your calculator, what you would have to do is you would have to do this one here. The reason for this is your calculator works from the left and upwards. I'm afraid you can't, unless you have a graphical one, you can't do something like that or something like that. So what you do is you say, well, the whole thing adds up to 1. That's where that 1 comes from there. And I'm going to remove the bits that I'm not interested in. That's how you kind of find this one here. A sketch helps it make a little bit more sense. Let's try another one. So Mashira reckons she has a 20% success rate. Well, I can see hypothesis, I can see 20%. So let's start doing something like this. A 20% chance of scoring penalties out of 15. Yeah, this sounds like an N value to me. Out of 15, she scores just 1. So that doesn't sound like a lot, does it? Scoring just 1. Let's keep an eye on that as well. Conduct a hypothesis test that her probability is different. Okay, this is an important phrase. So it means that this one here is going to look like this. Now, I know it feels like it should be less because it's just 1, but the key phrase is different. So this is what we're going to do. This is called a two-tailed test. When you have a two-tailed test, any significance level in the question, you're going to divide it by 2, because the idea is you're kind of sharing it out, a lower tail and upper tail. Okay, but, dividing it by 2 when you've got this symbol here. Okay, so we're going to have a situation. We didn't write this last time, but let's do that now to kind of make up for that. So 15 and 0.2, we're going to draw this one here, and we're going to have a think about what's going on. So here we go. 0 all the way up to 15 that's going off. This is what it looks like. Notice everything is kind of on the left. If you think 15, the middle is like 7.5, everything is over to the left. Well, that's because we're saying that you only scored 20% of the time. So we expect to see small numbers here. 20% of 15 is going to be around here somewhere. Okay, so what did we do? We said we are looking at 2.5% sort of on the lower tail over here somewhere, and we're going to look at 2.5% over here somewhere because it's a two-tailed test. So you've got to split your significance level evenly. So let's have a go now at working that one out. Okay, so I'm just checking if I have any more information. So we're going to just work this one out now. So our hypotheses, remember, need to be like this. You have to use these signs. You have to say H0, H1, okay? So you must make sure you're following all this kind of stuff. Now, I said we were binomially looking at 15 and 0.2. So what I'm going to do is I'm going to now test using my calculator. It was 1. I'm going to see what this probability actually is. I'm not going to do this bit because, well, the question's not asking me to do that bit, okay? So what I need to do now is with this on my calculator, I need to go to distribution. Okay, sorry, my calculator wasn't turning on. That's what that noise was. So we go to distribution. We're going to go to binomial CD. And we're going to type in this one here. So binomial CD, it needs to be. I'm going to click on variable. And I'm being asked about an X, an N, and a P. Now, N is 15, P is 0.2. What should this one be? I'm going to put in the value of 1. What this means when you put this value here is it means it will test, depending on your calculator, it will test going up to and including 1. That's what writing 1 like that means. So this is actually quite quick to work out. And when I type all of that in, the probability is, it is not that special. Okay, so it's 0.1671, lost to decimal places. In other words, if Mashira scores 20% of her kicks, if that's correct, getting 1 or less happens, it still happens almost 17% of the time. It's not special. It's not a special result. It is not going to cause us to change our mind from the default. So we are going to accept H0. Notice I'm mentioning H0 again. Let's put it in context. So I'm going to accept H0. There is, you can reject H1 if you like, but that's not necessary. Accept H0. There is not enough. Okay, it's not special enough. There is not enough evidence that the rate, that the probability, okay, the probability what? The probability she scores penalties is not less than, not more than, is different to 0.2. Really what I should do as well while I'm here is I should compare that to the significance level as well. So let's just make sure we do that as well. So this is much bigger than 0.025. Okay, there we go. So I've got my hypotheses. I've got some evidence that I'm using the model. I'm making the right conclusion and I'm putting it in context. These are all the elements that you need. So why don't you now have a go yourself with this one? Try kind of handling this one first before you have a go at the next one, and tell me what you think in the comments.